In this video, I'd like to continue discussing basic concepts in statistics that you're going to need as we move through this course. And today we're going to talk about an issue which is really at the core of data collection and what data you actually collect. And the issue deals with sample and population. Now, to start, I'd like to go back to something we spoke about in our last video. So let's talk about quantitative reasoning and reach some conclusions from things we learned in the last video. So think back for a second about the coffee experience. Think about how many times we went to the coffee shop. Think about how we did the analysis of the probability that we would have a good cup of coffee. And basically what we did is we went for 3 months in the second example we dealt with. We had 91 days. We counted the number of days that we had a good cup of coffee. We counted the number of days we had a bad cup of coffee. We worked out a ratio, which we translated into a probability. And we found out that basically 6 out of 7 times we had a good cup of coffee, and once out of 7 times we had a bad cup of coffee. Now, let's summarize that for a second so that we're all on the same page. So first of all, the frequency of an event is only meaningful if we know the total number of events being considered. This is a very, very basic aspect of any quantitative reasoning. A number can be large or small, but that is not meaningful unless we know what the total number of events that number is relating to. So the relationship between the number that's given to you and the total number of events is really important in order to understand what we're talking about. So if you think back to the coffee example, if I had 1 bad cup of coffee out of 7, the 1 bad cup of coffee is meaningful in the sense that it's a really small number compared to the 6. So it's, if you get the sense of that, it's the total number which is important. Now we can take that one step further, as we did last lesson. Within this total number of events, a higher frequency of occurrence is considered more characteristics of the context within which that total number was collected. So once again, in relation to the coffee experience, we basically had 6 good cups of coffee out of 7. So that means that this is a more characteristic feature of that coffee shop than having a bad cup of coffee. That takes us to point 3. Within this total, a small number of events is considered uncharacteristic. So it's uncharacteristic of the coffee shop that we were talking about to have a bad cup of coffee. It's not impossible. There's a probability, a 14% probability, as we worked out last week. But it's a small probability. So the probability is, the likelihood is that you'll have a good cup of coffee rather than a bad cup of coffee. We also worked out the following: the larger the total number of events that I have, the more I can trust the frequencies that are observed. So if I have a larger sample, and we'll talk about sample and population in just 1 second, but the larger the sample I have, the more trustworthy the data. When I went to the coffee shop once, that is not a good data set. And perhaps if I only went for a week, it wouldn't be a good data set. But having gone for 3 months, I think that's a pretty good data set. And the final point we made is that based on the ratio of events, I can create a probability excuse me, that offers some insight into what might happen in the future based on the idea that the future is like the past. So when I make that recommendation that you should go to the coffee shop that I've been talking about, that's based on the idea that I've been there for 3 months, I have quite a large body of data. The coffee is consistently good the majority of the time. Therefore, I think when you go next time, it will be good as well. So that's basically a summary of where we were. Now we're going to take this forward slightly. So this is the question: what is a total number of events? In other words, how much data do I actually have to collect? It's, first of all, real-world empirical observations that we collected. So I'm thinking about research experiences. We collect the data. And however much data we collect, like we went to the coffee shop for 3 months, that is the total number that we have. However, it's not actually the total number of events. In other words, if you think about the coffee shop, after I finished collecting data for 3 months, people are still going to the coffee shop. Apart from me, a couple of 100,000 people went to that coffee shop. So I don't really have the total number of events. I only have the total number of events in our sample. Does that make sense? So think about that for a second. I have the total number of events that I collected data for, but beyond that, there are many, many, many more events for which I did not collect data. Other people who went to the coffee shop in our example, a continuation of the time at the coffee shop. So our sample is the data I collected. Now it's important to point out the following. A sample is not a population. It's not the total number of events. Now, as researchers, on the whole, what we care about is the population and not the sample. So we have a slight problem here. We're interested in making a generalization about the whole, or if you like, the full population. But we're actually collecting data from a sample. Just by the way, the reason we do that is it's nearly impossible to collect the full population, even under the best of circumstances. And I'll talk about this actually at the end of this video in a real world example. Now, this is the issue. Between the sample and the population, because the sample is much smaller than the population, there's nearly always going to be a difference in the results we get from a sample and the population. The difference is because the sample is not the full population. There is always a level of difference between those two. So think about this for a second. We're interested in the population so that we can make a generalization. We collect data from a sample. The sample is smaller. In many, many cases, it's significantly on, a multitude of levels smaller than the population, and therefore we can expect to find some difference between the two. Now, that idea of the difference between the population and the sample has some technical names, which I'm now going to give you. If I could collect data from the full population, like the whole population that I'm talking about, we would call the statistics that we developed, we would call them a population parameter. In other words, it would be a description of the total population. However, for many practical reasons, this is usually impossible. The population samples are enormous. They have many, many, many people. They're very expensive to collect data from. In many cases, it's impossible to do. So it's very rare that we actually have population parameters. It does happen sometimes, but it's very, very rare. What we usually have is what are called sample statistics. In other words, we infer, we describe based on a particular sample. So it's not the whole population, it's a small section of that population, and we use sample statistics to describe the population because we cannot get the whole population. We could get the whole population, we would do our best to get it, but it's nearly always impossible to do that. So we're taking a smaller sample. Now, as I said before, there is a difference between the sample and the population, and that has a technical name. It's called sample error. The difference in the value of the sample statistic from the population parameter. Now, there is nearly always a difference because of the nature of the sample we've collected. We can, however, reduce the sampling error. And there's two ways we can do that. One is we can have relatively large samples in relation to the population size. So if we have 20% of the population, that's better than having 1% of the population. So the larger the sample, on the whole, the better the example we have, the better the data we have. The other thing we can do, which is very important, is we can make sure the sample is representative. So the features and characteristics of the sample we have match those of the population we are interested in. If they match in the same proportions, then we can make more valid statements about what is actually going on. So let's talk about this for a second before we delve into an example. A population and a sample have measurable characteristics, right? They could have a geographic distribution. They could have all sorts of individual characteristics like demographics, age, GPA, socioeconomic status, language type, type of education. I could go on. There's gender, and there's a multitude of these variables. The question is the degree to which the sample measures characteristics match the population characteristics. So if I think of a set of characteristics, set of population that I'm interested in, if I could match my sample to that population and then collected data from that sample, I would have a much better handle on what is actually going on. Remember that if we knew all the possible events in the population, or if we could survey the whole of the population, we would be able to make much better predictions of the future because we'd have knowledge of the total number. Now let's consider a real-world example that is relevant from the current time. A politician in country A makes the claim that 2 million COVID tests of residents have been conducted and results recorded. He claims this allows him to make a decision as to the degree to which the coronavirus has spread through the country. He is proud of the great job that has been done by his administration. Another politician in country B makes the same claim. They have tested 400,000 COVID-19 residents, and this allows him to make a decision as to the degree to which the coronavirus has spread through his country. He's also proud of the great job that has been done by his administration. Based on what you already know about reasoning with numbers and samples and population, are these claims valid? Which administration, in your opinion, has done a better job when it comes to testing their population? Which administration can make a decision as to the degree that the coronavirus has spread in the population? So take a few seconds to think about that. Look at the two examples, see what you think. And consider which country is doing better, and which administration has handled this issue better. Well, 2 million is a very large number and 5 times larger than 400,000. So on the face of it, it would seem the administration of country A has done a much better job than country B. But of course, this is very misleading, right? Because what we have here are samples. 2 million is a sample, 400,000 is a sample. The first thing we actually need to know is the size of the population of each of these countries. If we don't know the size of the population, in other words, if we don't know the total possible number of events, it's very difficult to make any sort of decision about what's actually going on here. So, for example, if country A has a population of 330 million and country B has a population of 2 million, this means that country A has tested only 0.6% of the population. In other words, a very, very small sample comparative to the population. And country B, on the other hand, has tested 20% of their population. So if we think about sample size in relation to country size, in relation to the full population, we would probably say that the administration of country B has done a far better job than country A. And they've done a better job just because they have a larger sample size relevant to the total number of possible events. So their sample is larger, and the larger sample on the whole gives you a better indication than a smaller sample. 0.6% of a total population seems like a very small sample. However, just having a larger sample is not actually enough. And it's not enough because what we need to know is the degree to which the sample matches the characteristics of the total population. So is this really a sample which has been designed for data collection based on the characteristics of the population? Or was it just a chance testing? In other words, there were enough tests over here, so they did them. There weren't enough tests over there, so they didn't do them. In this place, they didn't do any tests. In this place, they did a multitude of tests, an ad hoc collection of tests. If country A only tested 0.6% of the population, that's still 2 million tests, right? But had a very good representative model of the population. In other words, they covered all geographical areas and demographic groups. It's possible that they actually would be in a good situation to evaluate how prevalent COVID-19 is in the population. This is only possible if their sample actually matches the population. If, on the other hand, this is not a representative sample, but just a set of opportunistic tests, they really can say very little about the degree to which COVID-19 is in the population. So let's summarize this example. If you need to make a decision about the frequency of occurrence of a disease in a population, you can do one of two things. You can either test the complete population, count the frequency and occurrence of positive results from a COVID-19 test, and whatever those results were, they would tell you actually how many people in the country have COVID-19 at that moment in time. That's one thing you could do. On the other hand, you could also do the following. You could take a representative sample that has matching characteristics of the sample to the full population. And if you have a large enough representative sample, that will give you accurate results about what's going on in the population. Remember that the small ad hoc sample will not tell you anything about the frequency of occurrence in that population. So that's a small example from current events in relation to COVID-19. I hope this clears up for you and starts this process of understanding that the sample you collect for your own research is very important for what you can actually say. With that, we'll end here and we'll continue in our next video.